This video is for Homework in Mastery 6.5, Sections 10.6 and 18.1 in your textbook, Functions. When discussing functions, we need to understand what relations are. A relation is any set of ordered pairs. When we discuss this, we need to think about what the equation of a line actually means. What the equation of the line means is y depends on the value we put in for x. So y is dependent upon our x. And that is why we say that x is our independent variable and y is our dependent variable, because it depends on what we put in for x. When we look at domain and range of a relation, we're looking at the ordered pairs for that relation or that set of ordered pairs. And so what we're talking about when we say domain consists of the first coordinates in the ordered pairs, the x values. Domain is your x values. Range consists of the second coordinates in ordered pairs, which is your y values. So the domain in this set or relation is 3, 9, 10, 11, and 13. We tend to put them in order from least to greatest. While the range is going to be 5, 8, 12, and 15. Notice 12 is up there twice, but we only put it in our list once. It only has to be there one time. Notice x is our domain, y is our range. A function is a relation in which no two different ordered pairs have the same first coordinate. The domain does not repeat, or the x value does not repeat. And so this line shown here shows you in this box the ordered pairs that are attached to the dots shown. -3, 4, 0, 2, 3, 0. Notice, nothing in my domain is repeated. So this is a function. So let's look at some other examples. Let's first state the domain and the range of this relation, and then we will be able to determine whether the relation is a function or not. So remember what domain is? It is the first number in the coordinates. And so our domain is 2, 5, -3, 2, 1. Our range is 4, 4, 8, 6, and -7, as I've shown here. Notice I didn't put down the 2 twice or the 4 twice wherever I put the sets down. Now then, the question is this a function or not? Is this relation a function? The definition of function said that the relation could not have a domain that repeated itself. 2 here and a 2 here. This is not a function because two different ordered pairs have the same first coordinate. Now then, let's look at this. We want to graph y equals x squared. How do we do that? First, we want to begin by constructing a table of values. Remember from previous, we choose values for x and plug those in, and we'll get our y values. We have to be a little bit careful here to make sure that we get the actual shape. We have to choose negative and positive values. So I've chosen -2, -1, 0, 1, and 2 for my x values. And you can see how I've worked them out in this middle column. Y equals x squared. Y equals negative 2 squared, which is equal to 4. So I have an ordered pair, negative 2, 4. Negative 1 becomes 1. 0, 0, 1, 1, 2, 4. That's my first step for graphing this equation. My next step is to plot those points, as I have done here. Negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. My last step is to connect the points with a smooth curve, as shown. Let me just go ahead and say that anything with an x squared is going to be in this shape. It's what we call a parabola. Let's try another one. Graph y equals x squared plus 3. Let's use the same values of x as we did before. Negative 2, negative 1, 0, 1, and 2. Construct a table of the values. Have to be a little bit more careful here because I have to plug in my negative 2 for my x. And then don't forget to add that 3. So negative 2 squared becomes 4 plus 3. That gives me 7. Negative 1 squared is positive 1 plus 3 gives me 4. And so forth. So I have ordered pairs negative 2, 7, negative 1, 4, 0, 3, 1, 4, 2, 7. Let me just ask you, what would be considered my domain in this particular problem? My domain is my set of x values. So these would be considered my domain. What would be considered my range right now? That's correct, my y values. So these would be my range. Would this be considered a function? What was the definition of a function? My x values, or my domain, could not repeat. Do I have any repeating domains at this point? No, not at this point. So actually this will turn out to be a function. Let's go ahead and plot these points. Here they are. And then we'll draw a nice smooth curve through the points. Let's try another one. Oh, I switched it up on you a little bit. Graph x equals y squared plus 2. This time, since I already have the equation solved for x, I'm going to choose values for y. I'll choose y equal to negative 2, negative 1, 0, 1, and 2. And then I'll solve it. So I'll construct a table just like I have been, except I'm going to have y here, x here, and then I'm going to put the y here again. That way I can read off my ordered pairs easily. So I'm going to put negative 2 in place of y. Negative 2 squared is 4, plus 2 is 6. So my ordered pair is actually 6, negative 2. And I do the same thing. And I have the ordered pairs 6, negative 2, 3, negative 1, 2, 0, 3, 1, 6, 2. So what would be my domain? That's correct. This column would be my domain. What would be my range? My y column, my y values, is my range. Would this be considered a function? No, actually this is not considered a function because I have a 6 here in my domain and I have a 6 here in my domain. I also have a 3 here and a 3 here. So I have two different numbers that repeat in my domain. So this one actually cannot be a function. But let's go ahead and finish graphing it. I plot my points and then draw a curve through the points. If you're given a graph, there's a nice way to tell if it is a function or not. It's what we call the vertical line test. The vertical line test says if a vertical line can intersect the graph of a relation more than once, the relation is not a function. If no such line can be drawn, the relation is a function. This means if I draw a vertical line, I can only cross my graph one time, at any time, for it to be a function. So let's look at some examples. Here, determine whether this graph is a function or not. Well, if I draw a line here, vertical line here, how many times do I cross my graph? I cross once. What if I draw my vertical line here? How many times would I cross? I would cross once. What about over here? I would cross once. So, anywhere I draw my vertical line on this graph, I would only cross one time. So A is a function. Let's look at B. If I draw a vertical line here at the very end, how many times do I cross my graph? I only cross once, so it's a function, right? Ah, but wait. What if I draw my vertical line here? I cross two times. Vertical line test says I cannot cross it more than once. If I cross it more than once, it's not a function. What about a circle? If I draw a vertical line right here, or right here, I'm only going to cross once. So it's got to be a function, right? Well, but look at this vertical line. I cross once here, and once here. So a circle will not be a function. So the vertical line test is very handy when you're trying to look at a graph and determine if it is a function or not. We also get into what we consider function notation. F of x. F of x, don't panic, just means y. It's another term for y. It means that this is a function of x. If f of x is equal to 3x squared minus 4x plus 5, find each of the following. I want to find f of negative 2. What this is telling me to do is it tells me to replace my x everywhere in my equation with a negative 2. So f of negative 2 is equal to 3 times negative 2 squared minus 4 times a negative 2 plus 3. Notice I've rewritten this entire equation, but this time with negative 2's everywhere there's an x. And I'm going to simplify. Negative 2 squared becomes 4. I can continue simplifying. 3 times 4 is 12. Negative 4 times negative 2 becomes 8. 12 plus 8 plus 5 is 25. So f of negative 2 equals 25. What this means is at negative 2, at x equal negative 2, y is 25. We'll get into that a little bit more later. Let's try f of 4. What did I say to do? Replace all of your x's with 4, which is what I've done here. And then simplify. 4 squared becomes 16, and then 3 times 16 is 48. Negative 4 times 4 is negative 16. 48 minus 16 is 32, plus 5 gives me 37. You'll do the same thing with f of 0. You'll replace your x's with 0. And when you do that, 0 squared is still 0. 0 times 3 is 0. 4 times 0 is 0 plus 5. And I get f of 0 is equal to 5. Function notation is useful in solving many exercises. Again, as I said, what you're going to do is you're going to substitute your x for the given value of whatever is in the parentheses. Don't panic. F of x, h of x, all of those things just mean y. Okay? So let's continue. If h of x is equal to x squared minus 3x minus 1, find h of negative 2. So what does that tell me to do? It tells me to replace each of my x's with a negative 2. And it's good to get in the habit of writing your original equation and then writing the new one directly underneath it. That way you can see yourself replace this x with negative 2, replace this with negative 2, replace this with negative 2. Now notice I put this negative 2 in parentheses before I squared it. The reason why is it says that the entire x is squared. Well, my entire x is a negative 2. Then I'm going to simplify. Negative 2 squared will become 4. Negative 3 times negative 2 is 6 minus 1. 4 plus 6 is 10 minus 1, which will be 9. Let's try another one. This one looks a little bit scary, doesn't it? Let's start out with, for t of x equal to 6 over x minus 3, find t of 5. Let's start there. All I'm going to do is replace the x with 5. Notice I've rewritten the original problem and then right underneath it replaced the x with 5. And then I will simplify. 5 minus 3 is 2, so 6 divided by 2 is 3. So t of 5 is equal to 3. Now I want to find t of x minus 5. What this says is I'm going to replace this x right here with x minus 5, as shown here. Again, I have rewritten the original problem, and right underneath it I replace the x with the entire x minus 5. This x with the entire x minus 5. And then I will simplify it as much as possible. I can regroup. Negative 5 minus 3 will be x minus 8. So I have 6 over x minus 8. Now that's as simple as I can go on that problem. I still have an x in the problem, which is okay, because I have an x left here. Sometimes you will have variables left in your problem. Sometimes you will have only numbers left. Remember not to panic when you're looking at these. Whatever is inside the parentheses, whether you're looking at t of x, h of x, f of x, anything like that, whatever is inside that parentheses, replace every x in your equation with the entire parentheses. If you need help, please feel free to ask one of us.